Hello everyone and welcome back. Let's talk about another most commonly asked interview question. So we're given a collection of employees and we store that in a map data structure for a quick lookup or whatever. Okay, so we have a map data structure where we map the employee ID of type integer to the employee itself of type employee or an object. Okay, if we take a look at the employee class, here we have an employee class with ID, name, and department. And we have the constructor, the getters and setter, and toString. So I want to print it like this, okay? So what is our requirement? Our requirement is first we want to sort the collection based on the employee department. And we know in each department there could be multiple employees, right? And in each department, further we want to sort the employees based on their name. And if there are two or more employees in the department with the same name, then further we want to sort them based on their IDs. So a chain of sorting mechanism, how we can do that using map data structure. Okay, we can use a stream API to achieve this very easily. We know that we cannot directly apply a stream API on a map data structure. We can either apply a stream API on the entries or the keys of the map data structure or the values of the map data structure. So map data structure is used to store key value pairs. Okay, we map a key to a value. Here we map an ID to an employee object. Okay, this is a type and this is a type. So each pair in a map data structure is stored as an entry. Okay, each pair or key value pair is stored as an entry. If we take a look at here, if I say map dot entry, this is the type where we store each key value pair inside a map data structure. So let's if I can press Control and enter that, we know it's a type. It's an interface, it's a type. It takes two other values or two other types, a key and a value, and they can have their generics and they can have their own type. Okay, in our case the key is of type integer and the value is of type employee. Okay, so just remember that in map data structure, we use map data structure to store key value pairs, and each key value pair is stored inside an entry of type entry. Okay, and we can achieve each entry and apply some operation on that. So what I can do in order to apply um, a stream API on this map data structure, I can get a set of the entries. Okay, if I say map.entry set, we can say it's going to give me a collection of type set. Okay, once I get the set data structure, I can easily apply the stream API on that. Okay, so let's see, let's get the set of entries of the map. Then I'll say a stream, give me a stream of that. Then I can apply some intermediate or terminal operator. For example, I can do for each to print each element, or I can say sort it. Okay, I want to sort each element the of the of the map. So before that, let me quickly print that. Okay, I'll say s out b for sorting. Okay, I can use either for each or maybe a stream API. I'll say map.for each. I'm just gonna pass it a lambda. I'll say get the key. The lambda takes two argument, key and value, and just wanna print that. Okay, we know our key is of type integer and our value is of type employee. Okay, if I mouse hover on that employee v and here in integer k. Okay, I'll say id, give it a space, key, and maybe put a wide space, separator. Let's put an arrow, something like that, and I'll just print the value which is of type employee. Okay, and inside the employee, if I go and here we have a toString method, it's going to call the toString method of that, and we're printing each employee something like this: id equal to id, name equal to name, and department equal to department. Okay, let's quickly run it and see. So we have our collection as it is, it's not sorted. So first, our requirement is to sort them based on the department. Okay. Okay, and then further by their employee name and further by their employee ID. Okay, so what I can do, I can call sorted. If I press Ctrl P here, it's going to accept a comparator. We know what is comparable and comparator. I can either make my own comparator here, or I can pass a lambda function. We know that it takes two argument. I will say two argument of type entry, and entry has integer and an employee. Okay, what I can say, I can call them entry 1, or maybe let's call it e1 and e2. Okay, I'll have my lambda function. I know each of them are of type entry. I can get their keys or their values. I'll say e1 dot get value, which is of type employee, and from this employee I want to get the department name. Department dot is a string. We can compare that, compare to e2 dot get value, which is of type employee, dot get department. Okay, so now I'm sorting that based on their department. Let me quickly just comment this out, and just wanna, I can store it in a variable of type list or maybe dictionary, but here I just want to directly print them using the for each. I'll say s out. Okay, something like this. Let's see what we get here. Okay, we get a list of employee, but they're sorted this time based on their department. Okay, account come first, finance, HR, IT. Okay, now we have sorted them based on their department, and we want to chain multiple sorting. Okay, if I press here dot then, we cannot do that. Okay, dot then, we cannot do that. Other way to sort that, either we can, if we want to have only one sorting algorithm, we can just or mechanism, we can just pass a lambda function, or I can, if I press Ctrl P, it accepts a comparator, which is an interface. I'll say comparator dot comparing. It has a method comparing, and using this method I can chain multiple comparing mechanism or logic that I have. Okay, so if I press comparing, I can pass a lambda here. Let's say entry, let's call it entry, and in this lambda function I'll say entry dot get value dot get department, something like this. Okay, I get an error because I believe if I mouse hover over that, okay, our entry is of type entry integer, so I can maybe I can mention the type of this here. Maybe let's see, if I say map dot entry of type integer, my key is integer and my value is of employee. Okay, so we need to mention the type of that. Now if I run my code, I get the same output. Okay, no changes here, and if I want to reverse that, I can call the reverse function here, but for the moment I just want to have it in ascending order, the same output. But the good thing with this approach is that now I can chain as many sorting mechanism that as I want to this comparing method. Okay, I got this method. I just want to press enter, and I'll say then comparing. Once you compare based on the department, then in each department get an entry. Okay, get an entry again, and this time I'll say entry dot get value dot get name. Okay, then sort them based on the name of the employee. If I take a look at the IT here, first I have Sarah, I have Bob, Aaron, and John, Alex. So Aaron should come first, then Alex, then Bob, and so on and so forth. Let's quickly run that. If I take a look at the department, IT department, we can see we have 4 or 5 employees with different names, and they're sorted based on the name. Okay, do we have let's see, do we have, what I can do is I can enter some employee in the IT department with the repeated name. Okay, so here I have where is that? Maybe I can just control D here. Maybe I can give this one as a, or maybe change the ID of this. I will say this one as 112. Give it an ID of 112, and maybe give it another name or same name. Okay, same name, same department. So 12 come first, and 6 come first. 106 comes second. If I run that right now, we can see, where is that? We have 2 Aaron. Okay, 112 come first and 106 come second. So the other requirement is if 2 or more employees have the same name in a same department, then we want to sort them based on their ID. Okay, so this 106 should come first and 112 should go second. So then I can change another sorting here. Once I use the comparator, the comparing, I can chain as many sorting logic as I have. Then I'll say then comparing, then after that compare and sort based on get another entry. Let's say entry, this time entry dot get key. Okay, key is the ID of type integer. If I just run it. Now this time we can see, if I go to Aaron, where's Aaron? Yeah, 106 comes first and 112 comes after that. Okay, so this way we can chain and sort based on different fields of an object. Okay, so thank you so much for watching, and please don't forget to subscribe, and see you in the next video. Okay, this is the logic for sorting a collection of objects inside a map data structure. Okay, thank you.